This is a demo of a 1 million point FFT using the AI engines array in a Versal device. I will use AMD's example design as a reference to port it to a custom platform, build the bare metal application that runs the FFT, and then run it live on the Alpha Data PA100 board. As you can see, makefiles and Tickle scripts are provided to build the example design. And the initial script used to generate the hardware platform is here. Since the design is targeted to the VCK190 evaluation board, we will need to replace the default platform with Alpha Data's platform for the PA100 board. And you will notice that the script uses an extensive platform, and there is no option to include another board file. So we will create a new platform and then generate the image for programming the ACAP. For viewers of this video interested in learning how to build an extensive platform, you can find out more by watching the full version of this video. Let's check what's needed to build the example design now that we have our custom platform ready. The entry makefile builds the platform, but also names it. So we'll need to define the hardware definition file, which is here. We just created it. And then we'll need to define the Vitis platform that is going to be generated out of this hardware definition file. So because we have already created our platform, we'll just run the Vitis extensive platform creation. This Vitis script will create the necessary infrastructure to communicate the PS with the PL alongside with AI functions and stitch everything together so the host application can be run. So we can go to the package target, which contains the routines to generate the SD card image. Once we run it, we'll get the container with the specific AI engine-based application, and then the bootloader, which also contains the PS application that controls the program execution on the AI engines array. Let's call the makefile that creates all this. And as you can see, we have already generated all the targets. So all we need to do now is to go to the build folder, where we can see the SD card folder. And we can copy the files containing this folder, which are the ones we discussed earlier in this video. And yeah, these are the two binaries that are required to boot from the SD card. Let's run the 1 million point FFT on the custom board with the Versal ACAP device. The board is ready with the micro SD card with the binaries we just generated. So in order to run the 1 million point FFT, we'll need to boot from the micro SD card, and then the example will run automatically. And for that, I'll use this terminal here to open the serial port where the board is connected to. And then we'll be able to see the board booting. Now, in another terminal, we'll open the Vitis console and connect to the board. We have it connected with the JDAC cable, and then I just selected the Versal device, and I'm going to assert a system reset, which is equivalent to a PORB signal assertion. We can see on the terminal that the Versal bootloader is booting from the SD card. Next, the PS program runs the test showing the statistics of the cycles taken for processing and its latency with no mismatches compared to the expected output. Finally, we are presented with a summary of the 64 kernels running in parallel for the 1 million point FFT with input data of 32 bits floating point. Each core runs at 479.8 megasamples per second, achieving an overall data throughput of 30.7 gigasamples per second. an impressive figure. So that's it for the demo, and to learn more about the host application details and the FFT implementation, you can visit the link below. Thank you for watching.